continuity and common functions. All right, so I've said this in the past. There are three functions, functions, that you always want to be aware of that have domain issues. Domain issues. Do you remember which three functions I always say have domain issues? That's where we have discontinuities at commonly. All right, so the first one that I think of is 1 over x. Okay, what can x not be? For this one, x cannot be 0. All right, so whatever the bottom is, we would say the bottom cannot be equal to 0. All right, the next function that we always want to keep track of that we have issues is the square root of x. For the square root of x, where do we have issues? X cannot be or x, it's kind of easier to think about it where we have domain issues. X, I don't know how I'd say this, but it'd be like it can't be less than 0. It can't be less than 0 on this one. We can't have any negatives, no negatives. So in this case, x is greater than all values. X is greater than or equal to 0 for all values. For this one, it's negative infinity to 0, not including it, in union with 0 to positive infinity. All right, so this is the domain. This is not the domain. All right, and then, or where it's having issues at. And the last one, I think about it as a combination between these two. If we combine them, that gives us the issues for all logarithmic functions. Okay, for all logarithmic functions, if I combine these, x cannot be less than or equal to 0. All right, so then for this one, the domain for logarithms are x's all values greater than 0. All right, so this is how I kind of think about it. You're always looking at and considering the common functions that are these and where x cannot be equal to it. So this one is definitely okay because it doesn't fit any of these, but right here. So this would say, I would say, whatever the bottom is, in this case, the bottom is x squared, cannot equal 0. All right, so there's an issue when x is equal to 0 for this one. So which of the following functions are continuous for all real numbers? Just the bottom one, g only. Okay, so just keep these in mind as we go through. We need to refresh, that's fine. A little bit of loading time. Sorry about that. I'll go ahead and, while it's refreshing, clearing out. And we're loading up here. There we go. Limits and continuity. Where are there issues? So as we're letting it load, remind yourself, what are the three places that we have issues at? X on the bottom of a fraction, x inside a square root, and x inside a logarithm. All right. So already I'm seeing stuff, right? So was this one of them? No. X can be anything up here. It can be negatives, it can be positives, it can be 0. X is defined for exponential functions, but this is natural log. Remember, natural log is the same thing as log base e. So log of any number, we have issues. So x cannot be what on this one? It's easier to think about what it can't be. X cannot be any 0 or negative. You can always type it in a calculator. It's pretty easy for these just to see. So for this one, once again, it's g only. Next one, tangent and cotangent. Tangent. All right, so you have to think about it. And cotangent. So what's cotangent? So think about it in terms of what the tangent function looks like. So tangent. And you can always graph them. It's not too bad to graph on Desmos if you have that ability. So this is, when we get into trig, you got to kind of have a common knowledge of what those look like. So in this one, we have asymptotes at every pi over 2. it's pi intervals, but every pi over 2, there's like an asymptote on these for a normal tan function. So no good for tangent. I'm assuming cotangent probably looks like the same thing. Tangent is a sine over cosine. Cotangent is the reciprocal of that. So cotangent is cosine over sine. So just kind of thinking about it, where is there issues? When sine is 0. So the sine function, when is that 0? Okay, it's at 0, it's at pi, it's at 2 pi, right? So that means we're going to have asymptotes. So that's the tangent function. Like I said, I would just type it in on Desmos if you need to, but it helps to kind of figure it out. So that means for cotangent function, at every pi, it's going to pretty much probably be the same type of situation. So here's pi, 0, here's negative pi. My guess is we're having asymptotes. We're going to have an asymptote of 0, something like this. It's like, this is my guess, right? But I know there's going to be issues here. So that would be neither F or G are continuous, right? Okay, let's see. Well, I know tangent is continuous. Oh, at x equals 0. Okay, I thought it was all functions. So I should read questions better. So for at x equals 0, let's check it out. So 0, tangent is okay. Tangent is okay. What happens at 0 on cotangent? This one is no on cotangent. All right. So let's see which ones. No for cotangent, G. So F is continuous. Let's just double check in what cotangent looks like. I'm curious. So Desmos.com. And we're just graphing cotangent here just so it helps to kind of look at things that we don't know to be more informed in the future. All right, and how do I get the function? So it's like cotangent of x. Okay, so it was pretty similar. It's these kind of curved things going the other direction. Okay, so what I would do is I'll just go ahead and just make sure nice to edit your graph. So the real cotangent, I had the asymptotes, right? Tangent would go this way, so cotangent goes this way. Something like that. All right, and then I just like to confirm I'm doing this from memory. Then I look, it starts from the left and goes to the right. Yes, and it's every pi for those issue points. All right, cool. Next question, let's just see. And logarithm and cotangent. So, and let's be careful. They're switching the question. It was previously all real numbers, and they focused on a spot. So this would be no and no. So just going through like what we just talked about. Now we know. Be careful. Read your directions carefully. All right, and same thing. Careful. This is focusing at x equals 2. So we got a fourth root is a lot like a square root. We cannot have negatives under the square root sign. What number times itself 4 times is a negative. There is nothing. And then for just to see how domain looks on these, so keep practicing. It's really important. X minus 4 is everything inside the logarithm. So all of this has to be greater than 0. This is how the domain works. Domain works, all right? So what would this one be? All right, so everything under the radical, x minus 4 is everything under the radical, has to be what? It has to be greater than or equal to 0 on this one for domain. So it's helpful to think about what doesn't work to remind yourself, but this is what does work. So these are the domains, and you would solve for each one. I've gone this far. Might as well finish it off. So if we add 4 to both sides, just solving inequalities. So this one turns into x is greater than or equal to 4 here. This one turns into x is greater than 4 on this one. So x is greater than or equal to 4, x is greater than 4. Are we continuous at 2? Is 2 greater than or equal to 4? Is 2 greater than 4? No. So just from like algebraically, and you can plug it in, you'd get negatives. So it's neither. All right, so that's how we would kind of work with domain on this one.